Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from January 2024, paper 2. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 says, a ray of light in air is incident on a glass surface. The angle of incidence is less than the critical angle. So first of all, we can simply draw the line here. So this is representing the boundary. And it is given to us a ray of light is incident from air. So we can say this is air and here we have this one is glass. In this case, light is incident from air. So let's say it is incident at this angle. We can also draw a normal line here. So this is over normal line. So simply we can draw here. So this is normal line. And when this light will cross this boundary, it will bend towards normal. So we can use different color and we can draw the line here. So it will bend towards normal. It will go like this. So this is refraction. The second thing you need to understand, as there is angle of incidence that is less than the critical angle, so some of the light also will be reflected back. There will be reflection as well. Mean part of the light it will be reflected, part of the light it will be refracted. So based on this one we can find the answer. So this is partially means part of light is reflected and part of light is refracted. So if you look at given options, it is given to us partially reflected and partially transmitted. So this option is correct. Refracted away from the normal, this is incorrect. Totally internally reflected. This is only possible if angle of incidence, this is equal or greater than critical angle theta c. When theta I is greater than or equal to critical angle, there will be total internal reflection transmitted along the normal. This is only possible if angle of incidence is 0 degrees. So this is also incorrect. So the answer for this question is A. And for total internal reflection, you need to understand total internal reflection only take place if light travel from denser to less dense medium, denser to rare medium. So this is very important point for total internal reflection. So in this case, there will be no total internal reflection whatever is the angle, because the light is coming from less dense medium to denser medium. So in this case there will be no total internal reflection. Question 2 says, there is an increase in the intensity of light incident on a light dependent resistor. This causes a change in the number of conduction electrons and a change in the resistance of LDR. Which row of table describe these changes? So for LDR, there are few points you need to understand for LDR. If we sketch a graph between light intensities, so let me write on here. Let's say we have resistance on y-axis and we have light level, or you can say light intensity on x-axis. So the shape of the graph will be somewhat like this. So what this graph is telling us? This graph is telling us the resistance is very high. So we can say resistance is high. So this point is telling us resistance is high when the light is dim. Means when light intensity is lower, resistance is high. And if you look at this point, so we can draw here, resistance is low and intensity is high. So resistance at this point is lower as compared with this one, and light intensity is high. It means the light is brighter. So light is brighter. As the resistance is decreasing, it simply means that number of, so here let me write on here, resistance is decreasing with light intensity. It means that number of conduction electrons, they are increasing. Number of conduction electrons, they are increasing because LDR is made of semi-conducting material. Number of conduction electrons increases because LDR, this is made of semi-conducting material. Or simply you can say this is kind of semiconductor, or you can say semi-conducting material. It is made of semi-conducting material. So this is a kind of photoresistor, means its resistance depends on light. So if light intensity increase, its resistance decrease. Why resistance decrease? Because more conduction electrons. So more conduction electrons, it means current will be higher, so resistance will be lower for same PD. I hope this makes sense. Now if you look at given options, it is given to us number of conduction electrons decrease, no, increase. As the light intensity increase, it is given to us increase the intensity of light. So this is incorrect, this is also incorrect. So the answer is C, our answer is D. Resistance decrease, so this is correct. So it means answer for this question is C. This one is correct, but this one is incorrect. So the answer for this question is C. Very important point, you need this one for your exam. Third question says an electron has a de Broglie wavelength of 3.5 times 10 to minus 10 meters. Which of the following expressions gives the velocity of the electron in meters per second? So simply we need to understand de Broglie wavelength. De Broglie wavelength lambda, this is equal to h over p, and p is representing momentum of electron. So here we have h divided by m times p. We need to find the velocity, so simply we can rearrange this one. We can say v will be equal to h over m times lambda. M times lambda, and Planck's constant is equal to 6.63 times 10 to minus 34 joules second, and mass of electron is 9.11 times 10 to minus 31, and the speed is wavelength is given to us, so this is de Broglie wavelength, so we can plug in its value. So this is 3.5 times 10 to minus 10. So the answer, if you look at given options, so this is correct answer. So the answer for this one has to be A. Question 4 says, which of the following describes a change in energy of 1 electron volt? For this one, first of all, let's try to understand with this equation. Electrical potential energy, this is equal to Q times delta V. If charge on particle is 1e, means is equal to the charge on single electron, and potential difference between two plates, if that is equal to 1 volt, then energy gained by particle will be equal to 1 eV, 1 electron volt. What exactly it means? It simply means that we can imagine we have two plates. Let's say this plate is negatively charged and this plate is positively charged, and potential difference between these two plates is equal to 1 volt. I mean, if we connect a voltmeter between these two plates, and the reading on this voltmeter is 1 volt. And now if we imagine an electron placed at this point, then the initial velocity of this electron, let's say, is equal to 0. When this electron will reach this plate, how much energy, how much kinetic energy this electron will gain? That kinetic energy means we can say the change in kinetic energy, that will be equal to change in EPE, and that change in kinetic energy will be equal to 1 E, means the charge on electron, and it is accelerated through a potential difference of 1 volt. So the gain in kinetic energy will be equal to 1 electron volt. So this is meaning of electron volt. Electron volt is a very small quantity, so this is very small amount of energy, and this is equal to 1.6 times 10 to minus 19 joules. So very small amount of energy. Now if you look at given options, a charge of 1 coulomb, no. 1 charge on 1 single electron, so this is not possible. A charge of 1 coulomb, no. An electron is accelerated across a potential difference of 1 volt. Yes, this is right answer because the charge is equal to the charge on single electron. So this is right. There is a current of 1 ampere for a time of 1 second. So this is actually Q is equal to I times T. So in this case we have 1 ampere and we have 1 second. So this is equal to 1 coulomb. So this is also not answer. Question 5 says the diagram shows a 1.5 volt cell in a circuit with 2 resistors. The cell has negligible internal resistance. The switch is closed. What is the reading on the voltmeter? What is reading on this voltmeter? In order to answer this question, we will discuss when the switch is open and when the switch is closed, so you can have better understanding. If I want to answer this question very quickly, you can answer. You can simply see how current will flow, and then you can look at the resistance of total resistance of the circuit, and you can find out value of V. It's quite straightforward one, but let me explain you this one a little bit in detail. Switch is open. So first case we will discuss when switch is open, because you need to understand the concept not only to answer this question. So switch is open. So one case, when the switch is open, how current will flow? Current will flow like this. Current will flow like this. Current will not pass through this switch because its resistance is infinite. So current will flow like this. So if we need to find the value of current, that will be equal to 1.5 volts, means total PD in the circuit divided by total resistance in the circuit. So if we solve this one, we will get 0.1 amps. Now if you need to find the reading on this voltmeter when the switch is open, so we can say V across 10 ohms, this will be equal to 0.1 times 10. So this will be equal to 1 volt, and potential difference across this one will be equal to, if you connect your voltmeter here, let's say this is V1, reading on this one has to be equal to 0.5 volts. So this is how you can figure out when the switch is open. But for this question we need to consider when the switch is closed. So we can say switch is closed. When the switch is closed, current will flow like this. Current will flow from positive terminal, and if this switch is closed, current will follow the least path of resistance, means the path with least resistance, the lowest resistance. So current will flow like this, pass through this resistor and come to this point. So what is the total resistance in this loop? So we have total resistance R, that is equal to 10 ohms. So what is the reading on this voltmeter? So V is the reading, that will be equal to I times R. We don't need to calculate because we have only one resistor. So the total EMF, means total EMF of this cell, will be equal to the PD across this one. So this one has to be equal to 1.5 volts. So this is how you can answer. If you want to calculate value of current, for example, you can also find out 1.5, and this will be divided by 10. So we will get, this is 0.15. Now V will be equal to 0.15 multiplied by 10. So again you will get this is 1.5 volts. So in the exam, how you will answer this one? So first of all you have to draw this one. Then you can see there is only one resistor. So it means PD across resistor is equal to EMF of the cell. So answer for this question has to be D. So this is how you need to answer. In the exam, just simply when they ask you switch is closed, just draw this and see how many resistors are there. If there is only one resistor, then the PD across that resistor has to be equal to the EMF of the cell if cell has no internal resistance. Question 6 says a uniform wire is attached to a meter rule. The wire is connected in a circuit as shown in the figure. The distance D between the connections to the voltmeter is increased. The reading on the voltmeter changes. Which graph shows the relationship between V and D? So this question is about potentiometer, a typical type of question. Let me explain you this one in detail. So we need to understand first of all how we can find out value of V across wire, value of V. So V has to be equal to I times capital R, means current passing through that part of the wire time resistance of that part of the wire. Current, simply we can say this is I, and resistance will be equal to rho L times A. Rho L times A. And in this case, current passing through this wire is constant. The value of I is constant through this wire. Any part of the wire if we take, or we take the full wire, current passing is the same. Let's say current passing through this part of the wire is I. Current passing through this one is also I, and current I is also coming from this power supply, means total current in the circuit is also I. So current through any part of the wire is I. So this is the point you need to understand. Now in this case, I is constant, means current passing through any part of the wire, that is constant. Resistivity of the wire is constant because we are talking about same wire, and cross sectional area is also constant because this is given to us, this is a uniform wire. So it means all these quantities are constant. So simply we can say V across any part of the wire is simply equal to I times rho times A, but I times E divided by A, this is constant, and here we have L. So simply we can say V across any part of the wire, this is equal to some constant times L, or we can say V across wire is directly proportional to L. L is the distance. So in this case, this is D is the distance. If we go on increasing D, it means we will go on increasing. If we place this voltmeter initially at the same point, its two terminals are touching the same point, D will be 0. It means initial value of V will be 0 because at single point potential is the same. So difference in potential will be 0. So the reading on voltmeter also will be equal to 0. And so this is the main idea. V is directly proportional to L. L is length of that part of the wire, small part, we are measuring the PD across that. So we can say V across wire is directly proportional to D. So these two quantities are directly proportional. So the shape of the graph has to be this one. So this is directly proportional. So this is the answer for this question. So this is telling us initially is very high, then as D increase potential decrease, so this is wrong. This is telling us initially potential is very high, the reading on voltmeter is very high, and then as D is increasing potential is decreasing, then it start increasing. This is impossible. This is telling us initially potential is very high. Initially it has to be 0. When D is 0, when the two terminals of voltmeter they are at the one point, it means there is no potential difference, so voltmeter reading will be 0. And so the answer for this question has to be C. I hope this makes sense. Question 7 says, a microphone is attached to an oscilloscope. The microphone detects a sound. The trace displayed on the oscilloscope screen is shown as below. One horizontal division represents a time of 0.015 seconds. Which of the following expression gives the frequency of the sound in hertz? We need to calculate frequency, and frequency is equal to 1 over time period. 1 over time period. Then time period is the time taken to complete one cycle. So we need to look at one complete oscillation or one complete cycle. So this is one complete cycle. So simply we can draw this one. So this is representing one complete cycle. And this has 4 divisions. So this is 1 division, this is 2nd division, this is 3rd, and this is 4th. So we have 4 divisions. So simply 1 divided by 4 times 1 division. Time for 1 division. 1 division represents 0.15 seconds. Now if we simply solve, we will find the frequency. And if you look at given options, option D is the right answer. 1 over 4 times 0.015. So this is correct answer. Question 8 says, at a distance D from a point source of light, the intensity is I. Which of the following expressions gives the light intensity at a distance 2D from the source? So simply first of all we can imagine this one is the point source S. At distance t, the intensity is I, and at distance 2d we need to find out what is value of intensity. So this distance is 2d, so simply we can say this distance is 2d. For this one we need to understand intensity is equal to P over A, means power over surface area, and we can say this is energy over T times A. I'm just writing these things in detail so you can have better understanding. And surface area of a spherical shape, so this is 4 pi d square. From here we can see that I is equal to, because this quantity is constant, so we have E over T, we are looking at the same time, and here we have 4 pi. So these quantities are constant, so here we have 1 over d square. So we can simply say intensity is equal to some constant times 1 over d square, or we can say I times d square, this is equal to constant. So it means that I1 times d square, this has to be equal to I2 times d2 square. So we can say this is d1. So this is something, this relationship is very important. So here, now in this case intensity, we need to find out value of I2, means intensity nu, so we need to find I2. This has to be equal to I times d square divided by 2d square. So here we have 2d square, so we will get this is I, and here we have d square, this will be divided by 4 times d square. So d square cancel, so we will get I2 is I divided by 4. So this is the answer. So the answer for this question has to be B. So this is how you can approach, but in the exam you no need to do all these steps. Simply you need to understand that I times d square, this is equal to constant, and then you can plug in value of distance and you can find the new intensity. Or you can remember this one, so I is equal to K times 1 over d square. Question 9 says two polarizing filters X and Y are arranged between a light source and an observer as shown in the figure. The intensity of light reaching the observer is a maximum. The observer rotates filter X, the observer then rotates filter Y, so that the intensity of light is a maximum again. Which row of the table shows possible angles of rotation for the filters? So first of all, let's try to understand with the help of simple demonstration. Imagine that we have two filters, they are aligned like this, so the transmission axes are aligned, so the light can pass through them. Now if I rotate this filter, let's say by 90 degree, so it means there will be no transmission. But if I rotate by 180 degrees, so again maximum light will pass through this. So if angle of rotation, difference in angle of rotation of two filters is 180 degrees, so again maximum light will pass through. So that is the main point. So if you look at difference in angle of rotation of these two, this delta theta, this is 90 degrees. So it means in this case intensity will not be same as before. Actually that will be minimized, so I can simply say that will be minimized. So the proper way to say is minimum, we can say. So this will be minimum or minimized, you can say. In this case delta theta, you can say this is also 90 degrees, so it means also it will be minimum, it will be minimized. And in this case delta theta, you can say this is 180 degrees, so it will be again maximum. So here delta theta, this is 90, so it will be minimum, so we can say it will be minimum. So this is the main point you need to understand. If the difference in angle of rotation of two filters, I can keep this filter here and I can rotate this one by 180 degrees, or I can rotate this one by 90 degrees and this one I can rotate by 270. So the difference in angle of rotation again will be 180 degrees, so it means that light intensity of the light again will come back to the same value as before rotation. So the answer for this question has to be C. I hope this makes sense, and if you have questions you can ask in comments. And if this video was helpful, these videos are helping you, please like and subscribe and show your support by subscribing and liking these videos. Question 10 says, in an atom, an electron drops from energy level E2 to energy level E1 as shown in the figure. A photon of wavelength lambda is emitted. Which of the following expressions gives the energy E2? So for this question, first of all, we need to understand electron was at this level first. The electron has this much energy, then it jumps down to this energy level. So in this case, energy will be released. And this E2, this is higher energy level, means when electron was here, it has higher amount of energy, and when electron come down to lower energy level, its energy is lower. Now if we write down the energy difference, means E1 minus E2, this one will be equal to delta E, but this delta E is negative because this energy level is lower, this energy level is higher. So we can also say energy released is equal to the energy of the photon, means photon has this much energy, but you have to use this negative sign here because energy is released. That's the reason we are saying this is negative, because this energy level is lower, this one is higher. Very important one, try to understand. So in this case we can say E1 minus E2, this is equal to minus Hc over lambda. So we can multiply both sides by negative sign, so this is minus and this one will be positive then. So we can say here we have E2, we can write on E2 because minus minus it will be positive and E1 is negative. So we will have this is equal to Hc over lambda. So E2 simply will be equal to E1 plus Hc over lambda. So this is very important thing. The main purpose of this question is to confuse you with this negative sign. Another way to answer this question is, if you have better understanding, so simply we can say the energy difference in this case, this is equal to the energy of the photon. So we can say this is E2 minus E1 because the higher energy level, if you want to use positive sign here, so you can say Hc over lambda. So in this case E2, this will be equal to E1 plus Hc over lambda. So this will be the answer. But I would suggest follow this one, because most of the time students, they don't understand minus sign. They will often get confused with that. So try to use this approach. Practice this approach one time, two times. When you are very comfortable with this, it means you understand how to deal with negative signs, means the negative energy. Negative energy means that energy has been released. So because in this case photon is emitted, so energy has been released. So that's the point. Now if you look at given options, I hope simply you can find out this one is the answer. So B is the right answer. I hope this question makes sense. If this question makes sense and these videos are helping, please like and subscribe. And if you're looking for extra resources, join Patreon. On Patreon, you will see a lot of resources. That's all for today's video, and remaining questions I will try to upload as soon as possible. See you in next video.